Question 6, we have the cubic function. And again, we have a translation. So looking inside the asylum grouped with the x, it looks like we're going left 2, so we're actually going right 2. Outside the asylum, we're going down 4, and that's normal, so the y value of our critical point is -4. We also have multiplication by 3 outside the asylum, so that is a vertical stretch by 3. And it's normal because it's outside the asylum, so it looks like a stretch, and it is. First two rows of our t-chart is our parent function, which is the cubic, so we take our x values and cube them. Again, I take care of the translation with the critical point, and the only thing I do in the second set of t-charts is any multiplication. So in this case, with that vertical stretch by 3, we multiply all of our y values by 3 to get our new ordered pairs, to get our direction from the critical point for our new graph. So I started by plotting my critical point of 2, -4. And because of the vertical stretch by 3 and the cubic function is fairly skinny to begin with, this ends up being really skinny, and I could only fit 2 other points on the graph. The left one down 3 and the right one up 3. Make sure in a case like this that your graph still looks like the parent function. So even though this is almost like a line, you should still have a little bit of the curve to give the idea that it is still a cubic function. Domain and range for our cubic function is all real numbers for both, so that does not change based on any transformation. Next, we have our inverse function, our 1/x. On this one, all we have is a shift, so I only use the parent function t-chart. So my first shift is right 3, so the x value for my critical point is +3, and then down 4, so the y value of my critical point should be a -4, which is correct on the graph. So next, when we graph, what I do is I plot the critical point, knowing that this function has asymptotes, so then I make my asymptotes go through that critical point. So here we are at 3, -4, so we have a vertical asymptote through x equals 3, and a horizontal asymptote through y equals -4. The inverse squared function looks like the volcano, so once we get the t-chart for our parent function, we use those again as directions from the critical point to get our graph. And on the inverse square and the inverse function, it's really important to use those asymptotes to get your graph looking like it should. And again, the domain and the range will link to the critical point. For our domain, x cannot equal 3. You can think about that vertical line traveling across the graph, and it will hit a point on the graph everywhere, except for that vertical asymptote. And for our inverse square function, we don't get any negative values from the parent function. And since we didn't have a reflection, our range will be y is greater than -4. You can see that the graph starts just above our y asymptote. And finally, we have our inverse function. Again, on this one, we just have a shift, so we're going left 1. So our critical point is -1, +5. With no stretching, compressing, or reflections, I simply use the parent function t-chart. Again, that critical point is where the asymptotes meet on this one. So we have a vertical asymptote through x equals -1 and a horizontal asymptote through y equals 5. Using the t-chart as directions from my critical point to plot points on the graph, and then again using those asymptotes to get the curves for our hyperbola. Domain and range, again, notice that the domain and range link to the critical point. X cannot equal -1, we would have division by 0, and y cannot equal 5, because this is just the inverse function and not the inverse square. We do get positive and negative values out of the parent function, so we simply don't have any y values along that asymptote.